Identify the species undergoing oxidation and reduction in the following reaction. There are two ways you can find the answer here. The first one is on the basis of definition of oxidation and reduction. That is, if it is addition of electronegative element or more electronegative element, it is oxidation. Or if it is addition of electropositive element, it is reduction. So what we see here we have hydrogen and sulfur, here we have hydrogen and chlorine. So hydrogen is common, we can compare these two. Here hydrogen is attached to sulfur, here hydrogen is attached to chlorine. And if you see, you have phosphorus, sulfur, chlorine. Chlorine is towards right side of sulfur, it means chlorine is more electronegative. So if more electronegative element replaces less electronegative element, it is similar to addition of electronegative element. Now the reduction part. Here we have chlorine, here we have chlorine. And if we see here, hydrogen is being added to chlorine. You had only chlorine here, here you have hydrogen added to chlorine, and addition of any electropositive element is reduction. So it means this part will be reduction and this part will be oxidation. You can get the answer on the basis of oxidation number also, the same answer. Here hydrogen and hydrogen will have +1 oxidation state. You don't need to bother about. Oxidation state of hydrogen is not changing. Here oxidation state of sulfur will be X. Then it will be 2 times +1 of hydrogen equals to 0. X will be -2. So oxidation state of sulfur here is -2. Oxidation state of sulfur here is 0. It means increase in oxidation state, it is oxidation. Now consider this part, chlorine and chlorine. Here you have in all free forms the oxidation state is 0. Here oxidation state of chlorine, say it is X. Hydrogen has oxidation state +1. So +1 plus X will be 0. X will be -1. Here oxidation state of chlorine -1. 0 to -1 it is decrease. It means this is reduction. Now we need to identify the species undergoing oxidation and reduction. So because we know the oxidation and reduction part, this is going under oxidation. So H2S is oxidized and chlorine is reduced. Identify the species undergoing oxidation and reduction in the following reaction. Here we need to identify where oxidation is taking place, where reduction is taking place. There are two ways to get the answer. The first one is on the basis of electronegative element goes away. So oxygen was attached to fluorine, now it is removed, it moves away. So removal of electronegative element is reduction. So here electronegative element, that is oxygen, is removed, hence it is reduction. So this part is reduction. It means Fe3O4 is reduced. Now consider this one, aluminium to aluminium oxide. In elemental form, here you have aluminium and here oxygen is attached to aluminium. So actually it is addition of electronegative element. Addition of oxygen or any other electronegative element is oxidation. So this part is oxidation. It means aluminium is oxidized. Fe3O4 is reduced, aluminium is oxidized. There is another method also, another way to do it. You can get the answer on the basis of oxidation numbers also. Here iron and iron you have oxidation state of iron in free state is 0. Here you will say let it be X, then 3 times X plus 4 times oxygen, sum will be 0. 3x will be 4 to the 8, x is plus 8 by 3. So from plus 8 by 3 to 0, it is reduction. So from here you got Fe3O4 is reduced. Remember, when you calculate the oxidation state, you do not consider the stoichiometric coefficients. Remember, okay? Never. Stoichiometric coefficients are considered only in oxidation number method, where you need to equate the increase and decrease in oxidation state per molecule. Third step of oxidation number method of balancing the reactions. Otherwise, when you are calculating the oxidation number, you will never consider the stoichiometric coefficient. So you will not consider this 3 or this 4 here. Now consider this part, Al2, Al2O3. Here aluminium is in its free state, so it is 0, standard free state, oxidation state 0. Here sum of oxidation states will be 0. You have 2 aluminiums, let it be 2x plus 3 times oxygen, sum will be 0. 2x minus 6 equals to 0, x will be equal to 6 by 2, that is plus 3. It means oxidation state has increased, it is oxidation. Aluminium is oxidized. Identify the species undergoing oxidation and reduction in the following reaction. This is slightly tricky one. If you apply the concept as addition of hydrogen is reduction, you will not be able to get the answer, and there is reason for that, right? The definition of reduction is addition of. Reduction is addition of hydrogen or any electropositive element, because oxidation is addition of oxygen or any electronegative element. Reduction is addition of hydrogen or any electropositive element. But here if I apply this concept without considering the comparative electropositivity and electronegativity, my answer will be wrong. Hydrogen is electropositive, but not as compared to sodium. If I compare it with sodium, hydrogen is less electropositive than sodium. Sodium is highly electropositive. It means comparatively, hydrogen is electronegative than sodium, and addition of electronegative will be oxidation. So in this case it will actually be oxidation, and most of the students make mistake if they do not consider this concept. In this particular reaction, it is better to get the answer using oxidation number method. There are no chances of doing any mistake in that case. So remember, it is always comparative. Here, although we are adding hydrogen, hydrogen is less electropositive than sodium. It is actually electronegative, more electronegative than sodium. So that's why it is oxidation, it is not reduction. And similarly, consider here. Here you are adding sodium, which is electropositive. You are adding sodium to hydrogen. Here you had only hydrogen. Here you have sodium attached to hydrogen. More electropositive attached. It is actually reduction. You can get the same answer easily by using oxidation number method. So calculate the oxidation numbers. Sodium in its free form 0. Hydrogen in its free form 0. Sodium in its compounds always +1. Hydrogen in hydrides -1. Hydrogen has oxidation state -1 in its group 1 and group 2 hydrides, and here it is group 1 hydride. So that's why hydrogen will have oxidation state -1. Here sodium oxidation state increased, it is oxidation. Here hydrogen oxidation state decreased, it is reduction. It means sodium is oxidized, hydrogen is reduced. Identify the oxidant and reductant in the following reactions. Oxidant means the one which oxidizes the other substance. Means it gets reduced itself. So tricky one, sometimes students make mistakes here. Oxidant is that one which is getting reduced, and reductant is that one which reduces the other one, means it gets oxidized. So first we need to identify the oxidation part and reduction part. Here you have oxidation number 0 because zinc is in its standard free form. Here oxygen in its standard free form, oxidation state 0. Here zinc in its compound will have +2 oxidation state, here -2 oxygen. So it means here zinc oxidation number increased, it is oxidation part. Oxygen oxidation number decreased, this is reduction. This is reduction part. Zinc is oxidized. It means zinc is reductant. It is oxidized by what? It is oxidized by oxygen. It means oxygen is oxidant. Oxygen is reduced. Oxygen is reduced. Oxygen is reduced by what? By zinc. So that's why zinc is reducing agent. Zinc is reductant. Okay. Zinc is getting oxidized, and it is getting oxidized by oxygen here, by the other substance present in the reaction. It means oxygen is oxidant. Oxidant means oxidizing agent. Reductant means reducing agent. Reductant means reducing agent. Next, identify the oxidant and reductant. Again, calculate the oxidation number. Here oxidation number of carbon will be X plus 4 times plus 1 equals to 0. So it will be -4. Here carbon's oxidation number will be X plus 4 times chlorine minus 1 equals to 0. So X will be +4. It means this is oxidation half. Chlorine in its standard form, oxidation number 0. Here chlorine will have oxidation state -1. It is reduction in oxidation state 0 to -1. It is reduction part. So the species getting oxidized is reductant. Species getting reduced is oxidant. Next, identify the oxidant and reductant in the following reaction. Find the oxidation numbers. Iodine in its standard form 0. Here sum of all oxidation states will be -2. Sum of oxidation states of this part only. You will not consider the stoichiometric coefficient. So 2 times sulfur X plus 3 times oxygen -2, sum will be equal to -2, this part. It means it will be 2x minus 6 equals to -2. 2x equals to 6 minus 2 equals to 4, and x will be +2. So sulfur oxidation state here will be +2. Now calculate the oxidation state of iodine here. It is whatever charge, it is monoatomic ion, whatever is the charge, that is the oxidation state, -1. Here sum of all oxidation states will be -2. So 4 sulfurs, 4x plus 6 oxygens, 6 times -2 equals to overall charge -2. 4x minus 12 equals to -2. 4x equals to 12 minus 2, that is 10. X equals to 10 by 4, that is 2.5. So here oxidation state of sulfur is 2.5. So we can identify the oxidation and reduction now. 0 to -1, oxidation state of iodine, from 0 to -1, it is decreased. It means it is a reduction. Here oxidation state of sulfur from +2 to +2.5, it has increased. It means it is oxidation. The part which has got reduced is oxidant. The part which has got oxidized is reductant. Identify the oxidant and reductant in the following reaction. Calculate the oxidation states. Zinc in its standard form 0. Hydrogen monoatomic ion, whatever is the charge, that is oxidation state, +1. Monoatomic ion here also +2 is oxidation state. Hydrogen in its standard form 0. From 0 to +2 oxidation state, increase in oxidation state, zinc is getting oxidized. From +1 to 0 oxidation state, decrease in oxidation state means hydrogen ion getting reduced. The species which is getting reduced is oxidant. The species getting oxidized is reductant.